Let us see MCQs in communication. MCQs is multiple choice questions. So what is, this is the fill in the blanks, is a progressive decrease of signal strength with increasing distance. Can you answer it? It is attenuation. Attenuation is the progressive decrease of signal strength with increasing distance. As the distance increases, the signal strength they deteriorate or decreases. This is attenuation. So if K factor is greater than 1, K factor is greater than 1, the array beam is bent where? Towards the earth. Okay? This K factor, we'll see about this. And antenna separations in meters, which is required for optimum operation of space diversity system, can be calculated from. Now this R is effective earth radius, L is the path length. Means if these are two antennas, and we need to find out is the separation, antenna separation in meters, which is required for optimum operation of a space diversity system, which can be calculated from. And this is space diversity, which is given by which is the option? The option is 3 lambda r by l, where lambda is the wavelength, r is the effective earth radius, and l is the path length between 2 points. Rainfall is an important factor for fading of radio waves at frequency above, wave or propagation wave, they are affected by rainfall. But in which frequency? 10 gigahertz. 10 gigahertz and above. 10 gigahertz and above. Rainfall plays an important factor for creation of fading or application of some attenuation. But theoretically, electromagnetic radiation field strength varies in inverse proportion to the square of the distance, right? But when atmospheric attenuation effects and the absorption of the terrain are taken into account, the attenuation can be as high as the inverse of which power of the distance? Let me explain it again. Theoretically, electromagnetic radiation field varies in inverse proportionality, means just one power to the square of the distance. Okay, to the square of the distance, d to the power 2. Now, when this atmospheric attenuation effects and the absorption of the terrain are taken into account, the attenuation can be as high as the inverse of which power of the distance? Because now the atmospheric attenuation and this absorption of terrain is also taken into account. What is the answer? The answer is 6. It can be d to the power 6. Okay. What do you call an attenuation that occurs over many different wavelengths of the carrier? What is this fading called as? This is called as slow fading. So attenuation that occurs over many different wavelengths of the carrier, this is slow fading. Which of the reception below, or which are the reception problems below here, that is not due to multipath. Multipath, a signal is coming directly and a signal is coming from being refracted or reflected from some other man-made object or any other object which is able to reflect these waves. So they are a multipath, so it can combine in constructively and destructively also. So which of the reception problems below that is not due to multipath? Which one of this is? This is slow fading again. The answer is slow fading. Others are due to multipath, delayed spreading, relay fading, and random Doppler shift. Some of the other multipath criteria is there. Now, which causes multipath or frequency selective fading? What causes actually multipath or frequency selective fading? Which reflector? As I just suggested, if you have this sharp waves, where the waves are going to go? It is actually the large reflector. If large reflector is there, then it causes multipath or frequency selective fading. In microwave transmission using digital radio, What causes most intersymbol interference? Uh, intersymbol interference is a property in which one symbol or one signal they interfere with another signal and causing the noise to be created. Means that will actually not be considered as a actual signal. It will be considered as a noise. So intersymbol interference in microwave transmission using digital radio. What causes this intersymbol interference? It is delayed spreading, because the most important aspect behind it is multipath. A shipboard's equipment which measures the distance between the ship's bottom and the ocean floor. Ship bottom and the ocean floor. I'll be talking about few questions which are out of the order also, because anybody can ask anyone. The person who is sitting on that side is the master. So, which is the shipboard equipment? Can you judge? It is sonar. Okay. Sound detection and navigation and ranging. Sound navigation and ranging. In these sound waves are sent and they are being received back, and depending upon the time it has taken, because we know the speed of sound, and then the distance can be computed easily. The cavity resonator. What is the cavity resonator? Is equivalent to LC resonant circuit. Is a reflect klystron, has its output taken from the reflector plate, produces a frequency which is independent of the cavity size, or has a low Q quality factor for narrow operation. Is equivalent to the LC resonant circuit. The cavity resonator is equivalent to LC resonant circuit. Now, coupling into and out of a travelling wave tube can be accompanied by coupling into and out of the travelling wave tube. This can be accompanied by all of the above: waveguide match, cavity match, direct coax, helix match, all of the above. A high power microwave pulse of the order of megawatts can be generated by microwave pulse of order of megawatts. How can it be generated? It can be generated by magnetron. A travelling wave tube amplifies by virtue of what? It is by the absorption of energy by the signal from an electron stream. Right? Electron stream has energy, it absorbs that energy. Next is, what is the purpose of electromagnetic field which surrounds a travelling wave tube? Okay, it is to keep the electrons from spreading out. This is the purpose of the electromagnetic field which surrounds a travelling wave tube, to keep the electrons from spreading out. Which of the following is used as an oscillator device in SHF band? It is both BNC, tunnel diode, and klystron tube also. The microwave frequencies are normally regarded as those in the range of, it is 1 to 100 gigahertz. 1 to 100 gigahertz, they are microwave frequency, and generally tropospheric communication is done at 2 gigahertz. The highest frequency which a conventional vacuum tube oscillator can generate is not limited by what? It is not limited by the degree of emission from the cathode. It is not limited by the degree of emission from the cathode. As the electron beam moves through a klystron intercavity drift space, what happens? As the electron comes out or moves through a klystron intercavity drift space, the velocity modulation at the input cavity creates density modulation at the output cavity. Again, when the electron beam moves through a klystron intercavity drift space, the velocity modulation at the input cavity creates density modulation at the output cavity. Now, the frequency of the oscillation generated by magnetron is mainly determined by frequency of oscillator by magnetron is the dimension of each cavity resonator. Now, if the instantaneous RF radio frequency potentials on the two sides of the magnetron cavity are of opposite polarity, the operation is of pi mode. Now, the gun diode oscillator. The gun diode oscillator depends on the formation of charge domain, right? When ferrite devices can be used instead of this duplexer of isolate microwave transmitter and receiver, and both are connected to the same antenna, what ferrite device can be used? It is circulator. Circulator can be used instead of duplexer to isolate microwave transmitter and receiver when both are connected to the same antenna. Now, to achieve good bearing resolution when using pulse radar set, an important requirement is, can you guess? It is a narrow antenna beam width in the horizontal. So, when used in conjunction with a radar set, the purpose of an echo box is to provide an artificial target. Which of this is true? Which may be used to tune the radar receiver. So, when used in conjunction with radar set, the purpose of echo box is to provide an artificial target which may be used to tune the radar receiver. So, in a radar set receiver, the usual mixer stage is a silicon crystal. Clusteron oscillators are most often used in frequency range where used in 300 to 30,000 MHz. Oscillators of clusteron tube are maintained by bunches of electrons passing the cavity grid. Now, what allows microwave to pass in only one direction? This is a very important question. It's a ferrite emitter. Ferrite emitter, it is actually sending in one direction the microwave and allowing to pass only in one direction. In a SHF, a pulse radar set, a reflex clusteron can be used as a local oscillator. The class E emergency position indicating radio beacon, that is EPIRB. What is this? This must be capable of floating and being secured to a survivor, must have its battery replaced after emergency use, must be tested during the first 5 minutes of any hour. The class E emergency positioning indicating radio beacon has all these three properties. A PPI cathode ray tube are used on a radar set, indicates both the range and azimuth of a target. The resonant frequency of a cavity resonator, it depends on resonant frequency of a cavity resonator, it depends on the physical dimensions. The maximum usable range of usual radar set on any particular range setting is determined by the maximum usable range of usual radar set is determined by the interval between transmitted pulses. Now, a clusteron is oscillating at the frequency of its resonant cavity. If the reflector voltage is made slightly less negative, the frequency will decrease. The coarse frequency adjustment of a reflex clusteron is accomplished by adjusting the flexible wall of the resonant cavity. So, in a pulsed radar set, the STC circuit is used to reduce interference from the effects of C return. And in a pulse radar set, the function of the duplexer is to allow the transmitter and receiver to operate from a common antenna. So, the aqua DAC coating on the inside of PPI tube is as a second anode and to prevent the build-up of secondary field. So, if the duration of radar transmitted pulse on a particular range of operation is increased, the required bandwidth of the receivers IF amplifiers may be decreased, right? The main frequency determinant element of our claustron is resonant cavity. So a thin layer of dirt and grime covers the reflecting surface of the parabolic dish of a radar set. The particular effect on the performance of the radar will be no noticeable effect. So which of the following permits a microwave signal to travel in one direction with virtually no loss, but severely attenuates any signal attempting to travel in the reverse direction? It is isolator. So is it possible to increase the maximum range of a radar equipment by lowering the pulse frequency and all that? These options. It is possible to increase the maximum range of radar equipment by lowering the pulse frequency, raising the peak power of the transmitter, and narrowing the beam width and increasing the pulse range. So when it is desired that short-range targets be clearly seen on a pulse radar set, it is important that the receiver and the display system should have the shortest possible time. Which of the following is used in high power microwave oscillator? Again, it's magnetron. Which of the following operational frequency is used for the modern LoRaN navigation system? Which is the frequency? It is 100 kHz, LoRaN C. Which Ferrite device can be used? This we have already seen, I guess. Circulator. The pulse frequency is equal to duty cycle and pulse width. Okay, pulse frequency is duty cycle or pulse width. In a radar set, a blocking oscillator can be used to produce a trigger pulse from the transmitter. The intensity of the echoes, that is target definition on a PPI display, is determined by the pulse frequency and antenna rotation rate. A duplexer circuit allows the transmitter and receiver to operate from the same antenna with virtually no interaction. The circuit may be replaced by what circulator? Duplexer circuit can easily be replaced by this circulator. Now, which of the following frequencies are used by the class E EPIRP? It is used 156.76 and 156.8 megahertz. The repetition rate of pulse radar system indicates the frequencies of the duty cycle. The repetition rate of pulse radar system is frequency of the duty cycle. In a radar set, sensitivity time control unit can reduce C return response. Which of the following is the Ferrite device that buffers a microwave source from the effects of varying load, thereby preventing the formation of standing waves? It is isolator. Pulse radar set are primarily used to find the target range and bearing. So which of the following factors is mainly concerned in the design of antenna system for a pulse radar set? It is radio frequency. So in a radar set, receivers and AFC system can be used to maintain the desired claustron frequency. The input signal is introduced into the traveling wave tube at the cathode end of the helix. And the display on the PPI scope of a radar set will have greater intensity under which condition? Both lower antenna rotation speed and high pulse rotation. The operating frequency of LoRaN C lies within the LF band. Okay, low frequency band. The PPI tubes have an aqua DAC coating inside the tube. The purpose of the coating is to act as a second coat. We have seen this. Now, a traveling wave tube is used at frequencies in the order of 8000 MHz. The main benefits of using microwaves is very important. More spectrum space for signals. More spectrum is available for the signal. 1 to 100 GHz. Radio communication are regulated in, say, any of the country can be asked. Say Philippines, right? NTC. NTC is the answer. Which of the following is not a disadvantage of microwave? Which of these is not a disadvantage? High cost equipment, because once it has been used or once it is purchased, then you can have a very good communication out of it. Which of the following is a microwave frequency? This is 22 gigahertz. As I just suggested, 1 to 100 gigahertz microwave frequencies are there. So 22 gigahertz is in between them. So which of the following is not a common microwave application? Which is not a microwave application? Mobile radio. Mobile radio is not a common. Radar, telephone, satellite, all they use microwave communication. Now, which of the following is not a disadvantage? As I just said, high cost and 22 we have seen. And just to recall that mobile radio is not a common microwave application. Okay, coaxial cable is not widely used for long microwave transmission line because high losses in coaxial cable. And strip line and microstrip transmission lines are usually made with strip line and microstrip transmission line. They are made with PCBs. The most common cross section of waveguide is rectangle. It is rectangle. The waveguide has a cutoff frequency of 17 gigahertz. Which of the following signals will not be passed by waveguide? It's very easy because the cutoff frequency is 17 gigahertz. 15 is less than that. Others will pass. The signal propagation in a waveguide is by electric and magnetic field. So when the electric field is in a waveguide is perpendicular to the direction of the wave propagation, the mode is said to be transverse electric. The dominant mode in most rectangular waveguide is TE 1.0. The magnetic field is introduced into waveguide by a what? By probe. Magnetic field is introduced into waveguide by a probe. The half wavelength, this closed section of a waveguide that acts as a parallel resonant circuit is known as disc cavity resonator. And decreasing the volume of the cavity causes its resonance frequency to decrease. This is the popular microwave mixer diode. Hot carrier is the popular microwave mixer diode. Vacator and step recovery diodes are widely used in what type of circuit? It is frequency multiplier. So which diode is very popular? Microwave oscillator. It is GUN. GUN is a popular microwave oscillator. Which type of diode does not ordinarily operate with reverse bias? This tunnel. Low power gun diodes are replacing reflex clysterons. Low power guns. Which of the following is not a microwave tube? Cathode ray tube is not a microwave tube. Clysteron, magnetron, all these are. So in a clysteron amplifier, the velocity modulation of the electron beam is produced by cathode cavity. Reflex clysteron is used as or an oscillator. For proper operation, a magnetron must be accompanied by a permanent magnet. The operating frequency of clysteron magnetrons is set by the cavity resonators, and a magnetron is used only as an oscillator. The common application for magnetron is radar. So in TWT, the electron beam is the density modulated by helix. So the main advantage of a TWT over a clysteron for microwave application is wider band. The main advantage of TWT over a clysteron, wider bandwidth we have. High power TWTs are replacing what in microwave amplifier? They are clysterons. The most widely used microwave antenna is horn antenna. This is the measure of reliability expressed as the average number of hours between successive failures. This MTBF, mean time before failure. And an active microwave radio repeater that can provide drops and inserts is baseband repeater. If the correction factor K, which is 4/3, if you recall in the very first or second question, it was there the k is equal to 4 by 3 of the Earth curvature, the microwave beam would have a curvature that is what of the Earth? More than that of the Earth. Okay, curvature, if the correction is 4 by 3, because it is greater than 1, so it will always be greater than what is computed. So the optimal clearance for an obstacle in a microwave system is acceptable as a dash of the first Fresnel zone radius, 0.6 of the Fresnel zone radius. So the microwave beams curve the same than that of the Earth when the value of the correction value k equals what? It is infinite. If the value is infinite, the microwave beam curves is same as that of the Earth. So these were few MCQ questions, and we will be dealing more of them. Thank you so much. Take care of yourself.